Quad is commonly known to mean 4. We have quad bikes, quadrilaterals. The muscle quads are actually named that because they take 4 million hours to gain. And all this is why quadratic equations are equations featuring powers of x up to a maximum of 4. But unfortunately, that's not true at all. Quadratic equations are equations with an unknown value such as x or y, featuring this unknown to the power of 2 in some place. They're also a surprisingly large amount of the GCSE syllabus because, as we know, exam writers have no imagination or friends. The most simple kind of factorisation they can ask you to do is one where every term in an equation has one factor in common. For example, if we look at 2x squared plus 6x equals 0, we can see that both 2x squared and 6x are multiples of 2x. We can therefore divide both of these terms by 2x and put it on the outside of the bracket. This gives us two equations which mean the same thing, but one has been expanded and one has been factorised. If we want to solve this equation, we know that if two things are multiplied to make 0, we know that at least one of these terms must be 0. Therefore either 2x equals 0 or x plus 3 equals 0, x equals 0 or x equals minus 3. This could get much more complex though if they ask you to factorise something like 36a squared b c to the 6 plus 81a to the 4 c to the 5 plus 108a b cubed c cubed equals 0. We can eventually see though that the number in front of each term is always a multiple of 9, and each term has at least an a and a c cubed in common. We can therefore take out 9ac cubed and arrive at a term inside the brackets of 4abc cubed plus 9a cubed c squared plus 12b cubed, all equals 0. More commonly though, we can be asked to factorise an equation where there is not a common factor in each term. In this case, we're splitting the original equation into two factors which times together to make the equation again. The simplest form of these is something like x squared plus bx plus c equals 0, where b and c are certain numbers. We do these questions by finding two numbers, call them alpha and beta, which multiply together to make c and add together to make the number b. If we've been asked to factorise x squared plus 3x plus 2 equals 0, we can see we need two numbers, call them Ian and Roger, which times together to make 2 and add together to make 3. We can see that the only two numbers that this can work with are 2 and 1. This tells us that x squared plus 3x plus 2 can be factorised to get x plus 2 in one bracket and x plus 1 in the other, all equals 0. This works because the x's times together to create the x squared, and the number in each bracket times by the other x to give 2x plus 1x equaling 3x. The 2 is then multiplied by 1 to give us the 2. We can also see that once again, if two things are timed together to make 0, then one of these brackets must equal 0. X therefore has to be minus 2 or minus 1. We can also get much more saucy examples which should show you not to freak out when a negative is involved. If we look at x squared plus x minus 12, we follow the exact same idea and look for two numbers, call them a number and another number, which multiply together to make minus 12 and add together to make the plus 1 in front of the x. There are several pairs of numbers with a product of minus 12, but adding these together shows us that the only pair with a sum of 1 is 4 and minus 3. X squared plus x minus 12 can therefore be factorised to x plus 4 in one bracket and x minus 3 in another, all equaling 0. This leads us to solutions of x equals minus 4 or x equals 3. This has been a look at factorising the most basic of quadratic equations, but there's much more coming up, including this, and this, but not that. So do make sure you stay, subscribe, and the classic, alright, okay.